and it's a 2x5 table. For a 2x2 table, I think that would be a problem. I'm not so sure. Let me just look something up here. Let's see, assumptions, restrictions. Tables larger than 2x2. No more than 20% of the expected counts are less than 5, and individual expected counts are 1 or greater. So, Daniela, that seems to say to me that if you're dealing with something bigger than a 2x2 table, here, remember it's a different conditions for a 2x2 table and larger than a 2x2 table. But this says that you can have no more than 20% of the counts, expected counts to be less than 5. Okay, good. Actually, I only have 1 out of 10. Exactly. So you're in good shape with that table. In fact, given how hard it is to, like work up data sets and stuff like that, I'm thinking that we probably would have let you skate on it anyway and do the calculation as long as you noted that, that there's an issue with the expected value in those cells. Okay, matter of fact, you might want to. Well, this is just somebody's comment on SPSS notes and stuff like that. But I would look around, see if we have maybe a little bit more reliable source, and I would reference that in the when you do your presentation. Okay, that's the case for a 2x5 table. Okay, good. Anybody want to email me a data set that we can work with? Maybe something that you're working on with a project? Because I can go on and discuss some other stuff. Maybe I'll even like review homework 7, which is not, which is still can be submitted, and I'll still sneak a peek at homework 6 if you have to submit it late. But it might be a little bit of a ding on result on the grade or something like that if it's submitted after the late date. But I can look at it. Hang on a second here. Let me back up. You guys are getting ahead of me. I have a question about my data set of violent crimes. How would I go about converting? Oh, okay. That's an interesting question. The flu shot. Oh, open the floodgates here. That's Sylvia. That's a good question. I'll look around. We've been using that data set for some time. It might have come from a textbook. And I'm gonna have to look around and see where we came up with that data set. Worst comes to worst, we can attribute it, like to our class or to the school or something like that. But I think I may be able to find something on it. Now, converting it to data set of violent crimes. How would I go back converting? Okay, let me see if I can find that data set. I need to move this out of the way so I can see. File. This is the text version, Violent Crime Excel. Let's see if I have an SPSS version here. Okay, let me open this. Okay, here's our data on violent crime. Save as. I'll put this on the desktop. Okay, I had an Excel version of it. I probably have an S. And let me see if let me just look one more step here. Violent crime, SAV. Do I have one here? Here it is. Okay, I managed to find it as SPSS. I was going to convert it, but since we have this already. Okay. 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 Seems every time I do this, opens it a couple of times. Okay, so violent crime. Murder rate I'm thinking that's probably a rate per 10,000. Poverty rate is probably a percentage. High school graduation rate is probably a percentage. College graduation probably a percentage. Percentage of single parents is probably a percentage. Unemployment is almost definitely a percentage. Whether or not they live in a metropolitan area is also probably a percentage. So I'm thinking that violent crime, this number here, is the only one that's an absolute number. So in any case, since that's going to depend on the size of the population, right? And we don't know the size of the population, I would ignore that first column. And if I'm going to do anything, I'm going to use murder rate. So, for instance, if I wanted to convert this into categorical variables, like for instance, I'm going to do some descriptive statistics here. Analyze descriptive statistics, and I'm going to do all of these. Oops, except violent crime. I don't need that one. I just want to find the mean. So the average murder rate was 5.3. The average poverty rate was 19. I'm sorry, was 11. So I'm gonna say that a high murder rate. I'm gonna call a high murder rate like 6. And I'm gonna call a high poverty rate around 12. Let's say I want to define this as a high murder rate and a high poverty rate. Poverty being the exposure, high poverty rate being the bad exposure, and the murder rate being high or low based on whether it's over. I'm going to pick 6 or 7 as an arbitrary number. Okay, so I'm going to go in here and I'm going to go into the murder rate. Okay, and I'm going to say transform, and I'm going to recode this into a new variable. I'm going to make a new variable from this. And I'm going to take the murder rate and put it in there. And I'm going to say the output variable is going to be murder rate category, CAT. Uh, 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 and the label might be murder rate, high or low. Okay, and I'm going to say, okay, here's the old variable. The old variable, let me see here. Let's see. Da, da, da. Okay, for the old variable, I'm going to put in a range of 0 through, what do we say? I'm going to say 5.9 murder rate, right? I think what the average was. If it's 0 through 5.9, which is a low murder rate, I'm going to call it, the new value, I'm going to call it 2. Okay, why did I call this 2 instead of 1? Well, I want the high murder rate to be in the top row, so I'm going to give it the lower number. Okay, so I'm going to call this 2 instead of 1. I'm going to add it here. And next, I'm going to tell it, okay, for the for the, let's see again, for the values 6.0 through, I don't know what the highest is. I'm going to exclude that District of Columbia. So I'm gonna put in 20 because I know it's going to drop that one out, and it won't copy it out because that looks like an outlier anyway. 6.0 through 20, I'm going to call the new value 1 and add it. I'll say continue. And then let's see, I'll say go ahead and change. And I'm going to say, okay, let's see if we're successful. Okay, there's our output window. But our real information is here. Oh, notice it left out District of Columbia, which is what we were after. Okay, so Alabama has a low murder rate, a high murder rate, excuse me, one is a high murder rate because look at 7.4. But Alaska has a low murder rate because, and it's a 2, because it's under 6. See, so only the places that were over 6 have a value of 1. So that's how I would define that category. Where are we? Okay, let's see. Hang on a second. I'll get to these questions. I just want to go back to the question, make sure I answered it. 2x2 table. Okay, and I'm going to go to the next. I'm going to go ahead and transform the other variable, which was going to be poverty. Transform, recording different variables. Uh, okay, now this time I'm going to. Okay, this time I'm going to get poverty, and I forget what the average rate was. I think it was around 12 or something like that. The new variable is going to be poverty. Categories. Notice there's no spaces. And the O values. The O value is going to be, let's see, low poverty is going to be 0 through uh, uh, 12, 11.9. New value, and that new value is going to represent a 2 because that's the low one. That's the one that's not bad. I got to get rid of this. Get rid of this. And the next one's going to be 12 through, I'm going to call it 30, just to make sure I'm covered. And that value is going to be 1. And I'm going to say continue. I'm going to say go ahead and convert the variable. And I'm going to say OK. Okay, so now we have another category. This is a location that has low poverty and low murder rate. This has high poverty. Oops, I'm sorry, high poverty, high murder rate. Low poverty, low murder rate. Low poverty, low murder rate. Let's see if I can't find any that's crosses over. Here's a low poverty but a high murder rate. Excuse me, high poverty but a low murder rate. So now, if I'm going to analyze this, analyze, compare means. Let's see. Let's see what I want to do here. It's categorical now, so I'm going to do crosstabs. And in the rows, I'm going to put my new categories: poverty level in the rows, the exposure, and the outcome murder rate in the outcome. And I'm going to tell it to calculate my chi-square value. I'm going to tell it to calculate my observed and expected values and my percentages by rows. Continue, and I'm going to tell it to calculate my risks. Here's my risk. Cancel. Statistics should be in here. Risk. So I'm going to tell it to calculate everything at once because I don't have the time to do it individually, and see what happens. Okay, let's see. Our expected rate for high murder rate and high poverty level, expected rate was 6.7, but I got more than I expected, and I got less than I expected. So this is kind of like what I would expect to get. My risk of having a high murder rate, if there's a high poverty rate, is 47%, and the risk, if we have a low poverty rate, is only 20%. So the relative risk is a little over 2. So you see it down here, 2.3. The odds ratio is 3.4. Notice that 1 is excluded here, but not here. It's a close call. And if we look at our Pearson's chi-square, our Pearson's chi-square suggests that we can reject the null hypothesis here. That's a pretty good result. Here's something interesting, though. With the continuity correction, we can't reject the null hypothesis, right? So we got a little bit of a problem here. A 2x2 table, we're supposed to use the continuity correction, and we failed to reject the null hypothesis. Yet we're very close. Look, if we hadn't used the continuity correction for a 2x2 table, we would have rejected the null hypothesis. Not only that, but for the odds ratio, the odds was 3.4 times as likely for a community, for a state that has a high poverty rate to have a high murder rate. So the odds ratio suggests that, look, 1.07, 12, that you can reject the null hypothesis. But the relative risk, which says that the risk is 2.3 times as high, says that the 95% confidence interval is 0.99 to 5.3, You failed to reject the null hypothesis because you got one in between. So that's really an interesting result, right? That's a lot. That's something you can speculate about and talk about a little bit. But that's how you might do that conversion. Of course, with this data, you would probably not even do this. You would probably say, although we got into this very late in the semester, let's do a correlation instead. So you might take a graph, right? Oops. You might make a scatter plot graph, scatter dot, define, and I'm going to put in the x-axis, I'm going to put the poverty level, and in the y-axis, I'm going to put the murder rate. Okay, let's see if it looks like there's a correlation between these two. See what that graph looks like. Well, it's kind of all crunched down at the bottom, but it sure looks like as we go up that there is some kind of uh, uh, correlation here. And r squared set is the r. We're going to calculate the r value in a second, but it looks kind of like there is a correlation between these two. It's not real strong. R squared set is 18%, 0.18. That says that about 18% in the change in the murder rate can be attributed to the variability in murder rate can be attributed to the poverty rate. I'll bet you if we got rid of the District of Columbia here, and I'm going to go back and actually do that. I'm just going to delete it from this data set. The District of Columbia. I'm just going to delete it. I'm going to do that again. Analyze. Where's my correlation? Oh, actually, I did my graph first. Okay, my graph. Let's do my graph. Okay, let's do it again. See what it looks like this time. Oh, that's a lot better, right? Okay, we got the same r squared as it happens. You know, it's not such good luck, but it seems a lot clearer that there is a correlation, and we can actually do correlation and see what kind of numbers we get. See if it appears to be significant. Let's see correlation bivariate. Let's see murder rate and poverty. And I say okay, and it looks like that result, the R value for murder rate is 0.427. The Pearson's correlation for murder rate is 0.427. The R squared was 0.427 times 0.427. Okay, it appears that that's a statistically significant result, that there is a correlation between the two of them. If you want to get adventurous, and I know that was the last part of this last session of the semester, we really didn't get a homework going on it or anything like that, you might play around with doing a correlation instead of something categorical. But it looks like both of them give you some interesting results that you can play with. Okay, let me go back and catch up on questions here. Question about kind of my question about the project. I'm doing a flu shot. Oh, let me get to this. Oops. Every time somebody types in types into the chat box, it jumps. Sounds good. Question about my data set. Categories, we got that. My question is about the problem of doing a flu shot. I created a hypothesis about insurance and working. On a chi-square test, am I expected to explore all 6 of the variables in the flu shot data set? I'm having trouble doing that and keeping it to 8 pages. I can imagine. That's a good question. I wasn't really clear about that. Kim, I would consider that maybe you do like a detailed analysis of the variable that you're looking at, the insurance status, and that maybe that you just also mention that these other variables have some impact, or just like you can do the tests on them and mention if you see any other significant results. Maybe that's a good approach to it. Just emailing my data set for presentation. I'm doing paid. If you get a chance, let me just let's see. Uh, Maze, I'll take a look at that later on and email you. Let's see. Who keeps jumping? Okay. Yeah, Sylvia, I wouldn't try and compare the unemployment and violent crimes, because violent crimes is the number. It looks to me like that's the number of violent crimes that occurred in that, say, in that state in a month or something like that. It's not really a rate. So in other words, you really can't compare 244 violent crimes in Hawaii, to which seems like a very low number, to let's see how many it had in New York, to New York, 554, because it looks like that's saying that violent crime is higher in New York than in Hawaii. But you got to keep in mind, it's probably only a few million people living in Hawaii, but there's probably 20 million people living in New York. So you really need to have a rate. Now, if you knew the population, what you could do, and this is like a little bit going beyond the scope of what we were planning on doing, what you could do is actually look up the population of each one of these, make a new column, look up the population of each one of these, enter the population, and then do a violent crime rate per 10,000 or per 100,000. Actually calculate it for yourself. But I think it probably makes more sense to just use the murder rate that they're already giving you as the thing that you're going to use as your variable, and then compare it murder rate to poverty level, murder rate to high school graduation rate, murder rate to college graduation rate, murder rate to unemployment rate, and so on and so forth. I think that probably makes more sense. Is my null? Let's see. Okay. Simon understood my no an alternative hypothesis. One, state a no association between cholesterol level and education level. There is an association. Yeah, I think that's an acceptable null hypothesis. That's two-sided. You're not saying it's going to be bigger or lower, just different, right? In your alternative hypothesis. So if you can reject your null hypothesis, you're going to say, "Oh, I reject. There's no association, and I accept that there is an association." At this stage, you're not committing to whether it's higher or lower. Okay, can we take a look at assignments? Which assignment we talking about, Mesa? You mean like 7 or 7? Okay, let's take a look at it right now. Okay, let me get to assignment 7. Leave page. Assignment. Assignment 7. We got some documents that go with it. I'll get to those if we need them. I probably have them somewhere else. Okay, I click begin. Okay. Assignment 7 complete. Assignment 7. Okay, we don't need to know that. Question 1. State a null and alternative hypothesis for the proposed association. We're going to have to open that document, right? Assignment 7.doc. Let me move this out of the way. Assignment. Oh, how was that? 7.doc. Okay, let's open this up. Okay, let's take a look at this. Let me blow it up. Okay, total cholesterol by education represents the total cholesterol level measured in men 50-54. The data is organized into three values for the level of education: graduated high school, some college, and graduated college. The lowest level of education, middle level of education, high level of education. Thus, we have a categorical variable. Okay, that's three values associated with numerical, right? So, in other words, that's one category. That's one value. That's the second value, and that's the third value. Okay, it might be 1, 2, and 3, but we'll see it when we open up the data set, what numbers are represented. Open the file in SPSS, state a null and alternative hypothesis. We got that already, right? We said that there's no association between level of education and cholesterol levels. The alternative is that there is. Okay, state the value of the F statistic. We're going to do analysis of variance. We're doing analysis of variance because we have three groups. We're going to find the mean cholesterol for high school guys, mean cholesterol for some college guys, and mean cholesterol for graduated college. We're going to have three means, so we're comparing three means. If we're comparing just two, college to graduated college or high school to college, then we would do a t-test. We wouldn't need to do an analysis of variance, right? We're doing this because we have three groups instead of two, and we're breaking it up into three groups, but the numbers we're breaking up are numerical, so we have to compare the means of them. Okay, so I'm going to see if I can't find that TC by Ed, CVS by Ed, SAV. Here we go. Okay, now I'm not sure that this is the same data set exactly that we uploaded, because you can see I had a lot of different versions of it, but it probably is. I'm going to go into the variable view just so I can see what this data really looks like. Okay, education, right, is a numerical variable, right? I'm sorry, education is a nominal variable, right, and it has values. 1 represents graduated high school, 2 represents some college, and 3 represents graduated college. There's three values there. Okay, that's already been coded for you. Total cholesterol is a scalar or numeric variable, so we don't put anything in the values because each value is whatever the number is, right? So I'm going to go back to the data view. And here we go. This person's person number 1, they're in group 1. I seem to remember that being high school, right? And their cholesterol is 200. Next, second person's group 1. Their cholesterol is 198. If I'm not sure, I can always go up here to view and say, show me the value labels. And it'll convert this from that number into what that number represents. And it knows this because you told it this when you coded this into the values back here, right? Okay, so I'm going to go back here to data view, but you can leave it either way. It doesn't matter. I'm going to, for the time being, I'm going to just leave it that way. Okay, so now we're going to do an analysis of variance. Analyze. What is analysis of variance is another way of comparing means. The only difference between this, or the main difference between this and doing a t-test, is that in t-tests, we're working with two variables. When we do a analysis of variance, we're working with more than two variables in most cases. Okay, one-way analysis of variance. So now I have to decide what goes into the dependence list, what goes into the factors, right? Well, factor means to break up, right? Like when you factor a number, like number 8, you factor it into 2 and 4 because you multiply them together, it'll give you 8. So you're breaking it up into groups. Well, what are the groups that we want to factor or break this up into? Well, they're the education groups. So that's always going to be your nominal variable. You can see it by those different colored balls and stuff there, right? So that leaves the number to go into the dependence lists. Okay, so now it's going to do our analysis of variance. I don't need to go into that. It's going to do our analysis of variance right off the bat, which is what we are asking for so far. If we have a significant result in our analysis of variance, we may want to do some other tests, these post hoc tests. Let's save that for later. Let's just go ahead and do this. Okay, and it calculates the sum of squares between groups. If you go back to the May 5th lab, you'll see that we went through, you may remember we went through an example in Excel and an example in SPSS and so on and so forth. There's links to that on Blackboard in the announcements. And that'll link you into the multimedia section for that particular lab. So we actually calculated this once ourselves and with a simple data set. So sum of squares, the degrees of freedom, the mean squares between groups, mean squares within the groups, and it calculates an F value. Well, this F value, we see what it is, and we see the significance level is 0.004. In other words, if there's a significant difference between the means, we get a high value of F. If it's bigger than the critical value, which we could look up on a table for these for the total number of degrees of freedom, we could look that up, right? And if the F score exceeds that critical value, we reject the null hypothesis. SPS doesn't bother with that, showing you the table, because it actually calculates the probability, the p-value, or the probability of being wrong if you reject the null hypothesis. And since this is less than 5%, you can go ahead and reject the null hypothesis, right? So we reject the null hypothesis. Let's see what the other questions were. So we want to null an alternative hypothesis, calculate the F statistic, state your conclusions. Can you reject the null hypothesis, accept the Well, which of these can you do? Can you reject the null and accept the alternative, accept the null hypothesis, reject the alternative hypothesis, accept the null and reject the alternative hypothesis? I think that you probably guys will be able to figure that out for yourselves. State the p-value for your analysis. We just calculated that, right? We got that from our analysis of variance in SPSS based on your post hoc tests. Oh, well, now, didn't I just forget something? Okay, let's go back. And now this time, doesn't matter where I do it. I can even do it from the output table. I'm going to go back and I'm going to say compare means, one-way analysis of variance. It's still set up. SPSS is sticky that way. It remembers this stuff. Still set up the same way. So I'm going to click on post hoc tests. And did it suggest a particular post hoc test? Based, let's see. Based on your state the p-value from the okay. Now, so state p-value for independence. I got ahead of myself here. Under the assignment relative. Okay. Based on your post hoc tests, which values for the level of education suggest significant differences in total cholesterol? In other words, now we're going to go back and figure out whether the difference is in high school versus college graduates, some college versus college graduates, high school graduates versus some college, or for all of the groups are significantly different. Okay, so we're going to check off any of those that are relevant, that actually are true. Well, I'm going to use Bonferroni. Popular, could use Tukey, least squares. I'm going to use Bonferroni and see what I get. And say, okay. Okay, so now let's see what my multiple comparisons here tell me. My multiple comparisons here tell me that the level of significance, right? Remember, this has to be less than 0.05 for graduated high school versus graduated college. That's a significant result. For graduated college, high school versus some college, that's not a significant result. For some college versus graduated college, that's a significant result. So it's not true for all of the different comparisons, but it is true for graduated high school versus graduated college, and for some college versus graduated college. But it's not true for some college versus graduated high school, and so you'll have to check out. You have to figure out which box is there. You can go ahead and check that there is a significant difference. But for graduated high school versus graduated college, it is a significant result because this is less than 0.05. So high school versus graduate college. So high school, graduated college. So that one definitely we check off. I'll leave it up to you to decide on the others. Upload the assignment document. In other words, You want to take the output from this stuff, from SPSS. Oops. Let me go to my output window. Here's my output window. So for instance, I'm going to want to take that table, click on it, say copy, open a Word document. I'm ignoring the questions for now because it's hard for me. I got so many windows open. And paste it in here and make any comments I want to make and take the next table and so on and so forth, save the document and then upload it. Okay, you can do the same thing with tables. This is a skill probably you're starting to use now for your project as well, I would imagine.